this video, I will be talking about Kirchhoff's rules. So in physics, you can have a simple circuit, which is easy to solve for, but you can also have a complex circuit, which is difficult, where you have to use Kirchhoff's rules to find equations which will help you determine the currents in the circuit. The number of equations you use will equal the number of currents you have. Kirchhoff rules consist of two rules. We have the junction rule, which states that the sum of all currents entering a junction must equal the sum of all currents leaving that junction. As you can see here, I1 goes into the junction, and I2 and I3 leave the junction. So the second rule is the loop rule, which states that the algebraic sum of changes in potential around any closed circuit path must be zero. As you can see here, we've drawn our loop inside of our circuit. So a junction is a point where at least three circuit paths meet. As you can see here, we have circuit path 1, circuit path 2, circuit path 3 all coming together to form a junction. You can also see here that there are two junctions, however you only need one equation because each junction gives you the same equation. As you can see here, I1 and I2 come together and I3 comes out, so the equation is I1 plus I2 equals I3. So for the loop rule, loops typically go from the positive end of the battery to the negative end, but it doesn't really matter which way you go, it'll just change the sign of everything. When you cross a resistor in the same direction as the current, that's a drop in potential, so it's a negative change in potential as you can see here. However, on the other side, it is going opposite current, so it will be an increase, which will cause a positive change in potential. So once you derived all your equations from the loop and junction rule, you have to solve for I1 and I2 and I3 using algebra. Fun. Now you can solve complex circuits thanks to Kirchhoff and me.